Greeting, folks. So we're going to start today with the lecture on discrete probability distributions. It will be an introduction to it, and we'll follow up with the rest of it on different videos. So today I'm going to introduce you guys to the concept of discrete probability distribution, which is module 3, and how to set it up and how to label it, and what's the difference between a discrete probability distribution and a frequency table. You saw a frequency table in module 2 that looked something like that. You had two columns. One of them were your classes, and the other column were the corresponding frequencies for those classes. So say your classes were 0 to 20, 20 to 40, and I'm going to go up to 100, 40 to 60, 60 to 80, and 80 to 100. And let's say your frequencies are 10, 25, 15, and 8. You saw this table in module 2. We called it a grouped frequency table. We call this a frequency table because it's a table based on frequencies, obviously. So what's a probability distribution? Well, if you really wanted to know the real name of a probability distribution, if I were to name it myself, I would call this a probability table. Because what it really is exactly like a frequency table, but the classes are being replaced with what we call a random variable x, which is basically values assigned to outcomes of an experiment, and we replace the frequency with the probability, and that's why we call this a probability table, because it's a table based on probabilities. This is a table based on frequencies, so that's why we call it a frequency table. Now, let's say take the example of rolling a die. If I roll a fair die, what are my outcomes? My outcomes are 1, 2, 3, 4, 5, and 6. And what are my probabilities? Well, these are theoretical probabilities, so it's not based on some kind of a random experiment, so you don't need to count anything. This is just theoretical, so we all know that if you roll a fair die, the probability of getting a 1 is 1 out of 6. The probability of getting a 2 is 1 out of 6 as well, and so on. And ladies and gentlemen, now you have what we call a probability table, and a more elaborate name for it is what's called a discrete probability distribution. It basically completely defines the experiment. It tells you that if you conduct this experiment, these are all the outcomes that you could possibly have, and this is the frequency of these outcomes happening. That's what a probability table does. It tells you what kind of an outcomes are going to happen, and what's the probability of each one of them happening. And that's a probability table. Whereas a frequency table organizes your entire data set into range of values and basically said how many numbers are in each group. So that's why they call this a counting table, a frequency table, a table based on you counting outcomes. But here, this table is not based on counting outcomes. This table is based on calculating probabilities of the outcomes. And that's what we call a discrete probability distribution. I could have created a discrete probability distribution for the experiment of having the gender sequencing for 3 children. And that would have looked like, say, I am interested in the experiment of having 3 children, and my interest, my random variable, is the number of girls. You always need 2 things when you're setting up these probability distributions. You need to know what your experiment is, and you need to know specifically what you're looking for, what we call a random variable. But if I want to have 3 children, and my random variable is the number of girls that you could possibly have when you have 3 children, then naturally the values that this random variable is going to assign are going to be 0, 1, 2, and 3. Why? Because if you can have 3 children, none of them could be a girl, or one of them could be a girl, or 2 of them could be girls, or all 3 of them could be girls. So here are the outcomes, numerical values assigned to possible outcomes of that experiment. Now how are we going to calculate the probabilities? Well, I'll show you how to do it here, but on our next video, we will get into constructing these probability distributions, and we'll talk more about how to do it. But I'm just going to open it up at this point and say, for me to calculate the probability here, I have to pay attention to the fact that probability happens to be a fraction. And so therefore, every one of these is going to be a fraction. I have 3 children, so if you guys recall, 2 to the power of 3 is 8, so the total number of outcomes is 8, so that always goes in the denominator. And a problem because, well, how do I know what the probability is of having 0 girls, 1 girl? I mean, the number of outcomes that have 0 girls and the number of outcomes that have 1 girl, 2 girls, or 3 girls, and I don't know this. And the only way I know this is to basically have the whole experiment in front of me, so I could just look at it and count and figure out how many of the outcomes, how many of these 8 outcomes have 0 girls in it. In order for me to find out what goes up here, I have to figure out among all of these outcomes, how many of them have only 1 girl in it. So I'm going to do this pretty fast. If I write all the possible outcomes of 3 children, the gender sequences, using a tree diagram as I've shown you in class. So here are my 8 outcomes. This is the complete sample space of having 3 children, the gender sequencing. Now it's pretty simple because now all you have to do is look in here to see how many of these have 0 girls in it. And that's only 1. So therefore this is a 1. Then you say, let me cross that so I don't have to use it again. Then you say how many of them have only 1 girl in them. How many of these outcomes only have 1 G in it? 1, 2, 3. So the 3 here. How many of these outcomes have 2 girls in it? Only 2 girls. This one, and this one. So that's 3 as well. And how many of them have only 3 girls in them, sorry, and that's only 1 outcome. So that's just 1. So there is the probability distribution for the experiment of having 3 children, where you have a random variable happens to be the number of girls. That's a probability distribution, guys. That's what a probability distribution is. It's just another version of a frequency table. And on the next video, we'll actually get deep into constructing these frequency tables, and probability tables, and then show you all the tricks involved in doing it. Good luck and see you next time, guys.